1.6, okay, are rational functions. So today we're going to be talking about like vertical asymptotes, horizontal asymptotes, slant asymptotes, all of that today, okay? Rational function is the quotient of polynomial functions. Okay? Is the quotient of polynomial functions. And what's quotient? Division. Yep. Division. So it can be written in the form of f of x equal n of x divided by d of x, where n of x and d of x are polynomials, and d of x is not the zero polynomial. Why can't d of x be 0? You can't divide by 0, exactly. Okay. Find the domain of f of x equals 1 over x and discuss the behavior of f near at any excluded x values. Okay. So if I gave you the function of 1 over x, what does that kind of look like if you graphed it? Do you guys remember back in Algebra 1, Algebra 2? What's the only number you can't have for x? 0, right? We cannot have a 0. So remember, this is where that graph kind of approached, but never actually crossed it. Do you guys remember that one? Look at that. If I put in 1, 1 over 1 is 1. So we'd have the point 1, 1, right? 1, 1. If I put in 2, I'd have the point 1/2, right? If I plug in 3, I'd get 1/3, right? If I plug in -1, I get -1. If I plug in -2, I'd get -1/2, right? So that's why we have those two branches, okay? And we know if we have these two branches, okay, we know my x values can be every single number except for what? 0. So what's my domain? All real numbers except for 0. Okay, so all real numbers except when x equals 0. Okay. So what does it mean? We can approach the x-axis, but we actually never touch it. And same thing with the y-axis, right? We can approach the y-axis, but never actually touch it, right? So we actually have a vertical asymptote at x equals 0, don't we? And y equals 0? Yeah. Okay, so vertical and horizontal asymptotes. The line x equals a is a vertical asymptote of the graph of f of x when f of x approaches infinity or f of x approaches negative infinity. As x approaches a, either from the right or the left. Okay, so just like up here, we approach them, but we actually never cross them, right? The line of y equals b is the horizontal asymptote of the line of f when f of x approaches b. Same thing in that sense, okay? Right. The graph of f has a vertical asymptote at the zeros of d of x. And d of x is what we are dividing by, right? So you set the denominator equal to 0 and you find the x values, okay? That would be your vertical asymptote, okay? The graph of f has at most one horizontal asymptote determined by comparing the degrees of n of x and d of x. What's my degrees again? The exponent, the highest exponent, right? Okay. When the numerator's degree is less than the denominator's degree, okay, you will have the graph of y, the line of y equals 0, the x-axis, as a horizontal asymptote. So if the degree of the numerator is less than the degree of your denominator, you will have a horizontal asymptote at y equals 0, okay? when n equals m. So the degree of my numerator equals the degree of my denominator. The graph of f has a line of y equals a of n over b of m. To b. That's the ratio of your leading coefficients. Okay, do we know what a leading coefficient is again? Yes, it's that first number in the front, right? So you'll put the leading coefficient of your numerator over the leading coefficient of your denominator, okay, as the horizontal asymptote, okay? When the degree is greater than the degree of your denominator, there are no horizontal asymptotes. Okay. So like if I had x to the third over x, there would be no horizontal asymptote, okay? If we had like x squared over x cubed, we will have a horizontal asymptote over or at y equals 0, so the x-axis, okay? If we had like x squared over x squared, we will have a horizontal asymptote at the leading coefficient of the numerator over the leading coefficient of my denominator. What's my leading coefficients of both of these? 1. So it'd just be y equals 1. So that x-axis actually shifted up 1 unit. Okay, does that make sense? All right, find all vertical and horizontal asymptotes of the graph of each rational function. Okay, so first off, to find your vertical ones, can I factor the numerator or denominator? Or, yeah, can I factor both the numerator and denominator? No, I can only factor which one? The denominator, right? And if I factor the denominator, what do I get? X plus 1 times x minus 1. And I can't simplify anything from the top and the bottom, can I? No. So if I can't simplify anything, now we can find our vertical asymptote. And to find our vertical asymptote, remember, our x values, right, our denominator at x values can never equal what? 0, or the denominator can't equal 0. So we're going to set our denominator equal to 0 and solve. So what are my vertical asymptotes? X at x equals -1 and x equals +1. So these are my vertical asymptotes. Okay. So if I look at a graph, I'm not going to graph these, but at 1 and -1, we have these vertical asymptotes, meaning can I ever cross those? No. So actually for this one, I'm going to have a graph in between them and each on each side of them. Okay. Now for my horizontal asymptote, okay, first off, look at my degrees. Are my degrees, is my numerator greater than, equal to, or less than my denominator degree? They're equal. My degrees are equal, right? And if my degrees are equal, right, we will have a horizontal asymptote at y equals the leading coefficient over the leading coefficient. So what is my leading coefficient? So y equals a of n over b of n. So what's my leading coefficient of my numerator? So in on-factor form is 2 over, what's the leading coefficient of my denominator? 1. And what does 2 over 1 simplify to? 2. So we have a horizontal asymptote at y equals 2. So if I go here, we'd have a horizontal asymptote between there. So we can't cross it. We can approach it, but we can't cross it, can we? All right. All right, part B here. Okay. Can we factor both of those? Yeah, go ahead and factor both of those ones real quick. how would that factor? How would the numerator factor? X what? X minus 1 and x plus 2. What would my denominator factor to? X minus 3 and x plus 2. Is there anything we can simplify now since we're in multiplication? Yeah, what can I simplify to? I can cross out the x plus 2's, and that simplifies to what? X minus 1 over x minus 3, right? So now, based off of this, this is where we find our vertical asymptote. So then how do we find our vertical asymptote? We set our denominator equal to 0. So x minus 3 equals 0. So x would equal 3. So my vertical asymptote is x equals 3. Now for my horizontal asymptote, we have to look at my degrees. Are my degrees greater than, equal, or less than? Equal. So since they're equal, so my degrees are equal, so we'll have the equation of y equals my leading coefficient over my leading coefficient, right? So what are my leading coefficients here? 1s. So I get y equals 1, because 1 over 1 is 1. So we have a vertical asymptote at x equals 3, a horizontal asymptote at x equals 1. Okay. Any questions with that so far? All right, sketching a graph of a rational function, okay? So the first thing we always do is we want to simplify if possible, just like what we did here. Do we have any restrictions on the domain? Okay, so kind of looking at what we did. What can't x equal from that? Then we're going to find and plot the y-intercept. And how do we find a y-intercept? X is always what number? 0. So we're going to evaluate the function when x is equal to 0, right? Then we're going to find the zeros of your numerator. Okay. Then plot the corresponding x-intercepts. Then we'll find the zeros of your denominator. And that will give us our vertical asymptotes, won't it? The zeros of the denominator. Then we'll find and sketch the horizontal asymptotes. And then we're going to plot at least one point between and 1 point beyond each of the x-intercepts and the vertical asymptotes. Okay. And then obviously use your smooth curves to complete the graph, because they're rational functions, they have to be smooth, right? No zigzags, no sharp turns, anything like that. Okay. All right, so sketch the graph of g of x equals 3 over x minus 2 and state its domain. Well, we can do its domain right now, right? It's going to be what? All real numbers except what? Except 2, yeah. Except x equals 2. Why? Because your denominator can't equal 0. So what else does that x equal 2 mean? It's an asymptote. What type of asymptote? We have a vertical asymptote at x equals 2. Why? Because we set our denominator equal to 0 and solve, right? So we have this vertical asymptote at x equals 2. So now let's go ahead and find our y-intercepts. So kind of going through our list up there. our y-intercept. What do we know about the x-coordinate for a y-intercept? It is always 0. So I'm going to plug 0 in for x, and can I find y? Yeah. So g of x just means y. So y equals 3 over 0 minus 2. So what is 3 over 0 minus 2? Negative 3 over 2. So can I graph 0, negative 3 over 2? Now our x-intercepts, okay? Remember our x-intercepts are the zeros of my numerator, okay? So the x-intercepts is the 0 of your numerator. Well, do we have any zeros of the numerator? Can I set my numerator equal to 0 and solve for something? No. So we have no x-intercepts because we have no variables in the numerator, right? You guys okay with that? And then my horizontal asymptote, okay? Okay, so my horizontal asymptote, is my degree less than, greater than, or equal to the degree of my denominator? Well, what's the degree of the numerator? 0. Why? There's no variable, right? So what exponent would cancel out your variable? 0, right? Because x to the 0th power is 1. 1 times 3 would be 3, right? So my degree of the numerator, 0. What's the degree of my denominator? 1, right? So is my degree less than, equal, or greater than the denominator degree? Less than. So since it's less than, we know our horizontal asymptote is y equals 0 because the degree of the numerator is less than your degree of your denominator. Okay? So we also have this horizontal. Okay. So we know we're going to have 2 branches, right? Okay. So now we got to pick points, right? Okay. So we already have the y-intercept marked, right? So now let's go ahead and pick some points to the left and to the right of 0, okay? Before our asymptote, our vertical asymptote. So give me a number to the left of 0. Give me a number to the left of 0. -1. Give me one to the right of 0 that doesn't pass my vertical asymptote. 1, right? All right. So could I plug those values in and find my y-coordinate? Yeah. So let's plug in -1. 3 over -1 minus 2. So it's 3 over -1 minus 2. Huh? -1. So can I graph -1, -1? And let's do 1. 3 over 1 minus 2. And what do we get? -3. So now we have 1, -3. So can we draw this where we approach the asymptotes but never cross? Yeah, so we got the 1 branch. Now we got to pick numbers to the right of my vertical asymptote. So give me a couple of numbers that are to the right of my vertical asymptote. My vertical asymptote is x equals 2. So give me some numbers to the right of 2. 3. Maybe 4 and 5, something like that. Try. At least give us 3 numbers to give an idea. Now, you don't only need to do 2, but let's practice. All right, let's do 3. 3 over 3 minus 2 is what? 3. So we have 3, 3. Let's do 4. 3 over 4 minus 2? 3 over 2, so 1 1/2. It's kind of the exact same as our y-intercept, right? Because aren't they going to be symmetric around the vertical asymptote? Yeah. And then 5, 3 over 5 minus 2. Isn't that 1? 5, 1. And there you go. Any questions on that one? All right, I'm going to go ahead and skip example 4 because this one's the exact same pretty much as that. I meant to do a different one. All right, so let's look at example 5. Okay, sketch the graph of f of x equals x over x squared minus x minus 2. Okay, so let's first start with what are my, we could do our asymptotes first, our y-intercepts, x-intercepts. What do you guys want to do first? Let's do our y-intercept. Okay, so our y-intercept. If I want a y-intercept, what do I plug in for x? 0. And if I plug in 0, what do we get? We don't even need to do the math, do we? What's 0 over anything? 0. So we have a y-intercept of 0, 0. Right there. All right, x-intercept. Remember, the x-intercept is the 0 of your numerator, right? The 0 of your numerator. Well, what's my numerator? X, right? And if what's my 0 of x? X equals 0. So wouldn't that also be 0, 0? That makes sense, doesn't it? All right, now let's go ahead and find our vertical asymptotes. Okay. If I want the vertical asymptote, what do I have to do with that denominator? Set it equal to 0. So x squared minus x minus 2 equals 0. So we need to factor it. So what do we get when we factor? X. Yep, x minus 2 and x plus 1. So my vertical asymptotes are x equals 2 and negative 1. So at 2, we have a vertical asymptote. And at negative 1, we have a vertical asymptote. So we know we're going to have graphs in the middle of those asymptotes and one on each side of those, don't I? Okay. Now we got to find our horizontal asymptote. Okay. So horizontal asymptote, what's my degree of my numerator? 1. What's my degree of my denominator? It's 2, right? Okay, so my degree of my numerator, is it less than, equal to, or greater than the degree of my denominator? It is less than, and since it's less than, my horizontal is y equals 0. Okay, y equals 0. All right, so now we got to pick some points, right? Now we got to pick points in between the vertical and on the outside of the vertical. So let's do the outside first. Okay, let's do to the left of negative 1. So give me some numbers to the left of negative 1. Do negative 2, negative 3, and maybe negative 4. Can you guys plug values in and find that? Yes, no? Yeah, hope so. All right, go ahead and do that for me. So this is left of negative 1. You guys get negative 1/2 for negative 2? Yeah, okay, good. And then if I plug in negative 3, did you get 10? Oh, sorry, negative 3 over 10, right? Negative 3/10. Yeah. Got the numerator on that one. And then negative 4 over 18, which is negative 2/9. So if you notice, it's getting smaller and smaller, isn't it? Yeah. So we're at negative 2, negative 1/2, smaller, smaller. We know it's something like this, right? It's just really, really small, correct? All right, let's pick some values between the isotopes. So what numbers are between my isotopes? 0 and 1. So let's plug that in. 0 over anything is 0. All right, let's do 1. So we're going to get 1 over 1 minus 1, negative 2. 1 over negative 2. So negative 1/2. Is that what you guys got? So this one actually kind of curves like this. Yeah. And then now we need to do the right of 2. So what numbers are to the right? 3 and 4. We can do 5 too, but we can only, if you want, we'll just do 2. So we have 3 over 3 squared, 9 minus 3, 6 minus 2, 4. So 3/4. 4 over 10, which is 2/5. So can we get an idea where it's going to be? Maybe something like this. There we go. Any questions with that? You guys okay with this? Seem okay? Okay. All right, do we need to graph example 6 too? It's the exact same thing as this. You guys feel okay? This are, example 4 and 6 are the checkpoints, so there are videos for those checkpoint ones too if you want to go in there and look at that, okay? All right, slant isotopes. Okay? If the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph of the function has a slant isotope, okay? It will have a slant isotope. We'll talk about that, okay? All right, now, excuse me. All right, so go ahead here. Here we're going to have a slant isotope, right? To sketch the graph. Okay, now let's go ahead and I want you guys to start and I want you to find your y-intercept, your x-intercept, your vertical isotope, and your horizontal. And we'll talk about the slant one here in a second. So you guys go do those ones real quick for me. Explain how to find the slant here in a second. right, so my y-intercept, how do we find our y-intercept here? We plug 0 in for x, and we solve, right? So in the numerator, if I plug 0, what do I have? -2. And when I plug 0 in the denominator, I get -1. So what's -2 over -1? 2. To find my x-intercepts, I look for the zeros in my numerator, right? So how do if I look at my numerator, we have x squared minus x minus 2. We set it equal to 0. So how do I find my intercepts here? Factor. And what do we get when we factor? X plus 1, x minus 2. So what are my intercepts? 2, 0, and -1, 0. Now, could I graph all this information as I'm doing this? Yeah, don't worry about it. My vertical asymptote is found by looking at my denominator, right? Okay, so to find my denominator, x minus 1 equals 0. So my vertical asymptote is x equals 1. So x equals 1. The ugly line. And then my horizontal asymptote, okay, is my degree. What's my degree of my numerator? 2. What's the degree of my denominator? 1. Okay. So now, since we have a degree of 2 over 1, and the degree of 1, is that degree less than, equal, or greater? Greater. So what is my horizontal asymptote, or do we not have one? What does it say? If the degree is greater than m, then the graph has no horizontal asymptote. Okay, so we actually have no horizontal asymptote because the degree is greater than the degree of the degree of the denominator. Okay, now we do have a slant one. Why do we have a slant one? Because the degree is exactly 1 more. Okay, so to find my slant asymptote, we use long division. Long division, okay? Do we know how to use long division? Please say yeah. Yeah, okay. What goes underneath my division ball? X squared minus x minus 2. What's my divisor? X minus 1, right? All right. So now look in here, okay? X goes into x squared how many times? X. And then what's x times x? X squared, right? And x times -1? -x, right? And then we subtract, right? What's x squared minus x squared? Nothing. What's a -x minus a -x? Nothing. And we're left with a -2. Can x go into -2? No. So this here is known as my remainder, right? So your slant asymptote is actually y equals what we first divided by. And that would be just x. Okay, so not the divide, not the remainder, it's what the numerator, what it can actually go into it. Okay, so if on the top here was like x plus 1, my slant asymptote would be y equals x plus 1. Okay, does that make sense so far? All right, so now we have an asymptote of x equals 1. We have this slant asymptote here. Okay, so we have this vertical asymptote, and then we have this slant asymptote. What else do we have? I can't draw right now, sorry. All right. Now, can I graph my y-intercept? Can you guys draw your y-intercept? or graph your y-intercept of 0, 2? Yes. Can you graph 2, 0 and negative 1, 0? My graph is a little off there, but that's all right. All right. Now, can we pick points around those two? And remember, we have this vertical asymptote here. So we only need one more point on this side. So could I do like 1/2, plug in 1/2 if I really wanted to? Or just know it's going to approach this and approach my asymptotes, right? Now for this one here, all we have on the right side here is 2, right? So we need to pick another point. What's to the right of 2? 3. So let's plug in 3 up there. So what's 3 squared? 9. 9 minus 3? 6. 6 minus 2 is 4. Over, what's 3 minus 1? 2. So we have the point of 3, 2 also. So we know it's going to approach this direction. And there you go. Any questions with that so far? All right, so a lot of memorization on looking at those degrees, I think, right? They're less than, okay? We know that we have a horizontal asymptote at y equals 0. If it's greater than, we have no horizontal asymptote, okay? If they're equal, we have it at y equals 0, right? Okay. All right, any questions with that one? Okay. All right, do we want to do the story problem, or do you guys want to look through it in the book? Up to you. Yes, no? You guys awake today? No? No, not at all. All right. Now, some of these things too, we don't have graphing calculators, but sometimes would it be easy to use? Have you guys looked at Desmos.com with the graphing calculator? Plug those in with that, okay? It'll help you kind of, if you're not sure how something's supposed to look, use that as a tool. Don't copy it, but use it as a tool also, okay? All right. Let's go ahead and go to the other one then. All right, so nonlinear inequalities, which you guys know inequalities are what? Greater than, less than, greater than or equal to, less than or equal to, all of that fun stuff, okay? Nonlinear means what? It's not a line, right? Now, remember, if it has a line underneath like equal to, those are solid lines, right? If it's just less than or greater than, they're just dashed lines or dotted lines, however you want to look at it, right? Okay. Now, key numbers are zeros of the inequality, and the resultant open intervals are the test intervals, which will be important for us. Okay, we need to know test intervals. Okay. Now, to determine these intervals, okay, of the values upon are entirely negative or entirely positive, we're going to use the steps below. Okay. So we're going to find all real zeros, not imaginary, all of our real ones, okay? And then we're going to arrange the zeros in order, okay? And they're going to be in increasing order. These zeros are the key numbers of the inequalities, okay? The key numbers. We will then use those numbers that we have to determine our test intervals. I don't know why I kind of zoned out there for a second. Our test intervals. We'll choose one representative x value at each test interval and evaluate the polynomials at the number. Evaluate means we just plug in and simplify, plug in and solve, right? Okay. When the value is negative, the polynomial has negative values for every x value in the interval. Okay. When the value is positive, it has positive values for every x value in our interval. Okay. Right. Solve x squared minus x minus 6 is less than 0, then graph the solution set. Okay. Now, if you saw this right off the bat, you would think to do what? Factor. Guess what? You're doing the same thing here. We're going to factor this. Okay. And when I factor this, what do I get? X plus 2 and x minus 3. Yep. Okay. And now, can we set each part equal to 0? Yeah, so x would equal negative 2 and x would equal 3. Okay, so these are my key numbers. Okay, these are my key numbers. Okay. So the inequalities test intervals, okay, will be, since negative 2, if we're listing them from increasing order, it's negative 2 to 3, right? Okay. So we're going to pick, so we're looking at a number line here, okay? So negative 2 is my smallest, so we're going to go from negative infinity to negative 2. We will go from negative 2 to 3, and then we'll go from 3 to what? Positive infinity, okay? So those are our testing intervals, okay? So what we do here, okay? So when we test, we need to pick a number that is in between my first test interval. So give me a number in my first test interval. Huh? Negative infinity to negative 2? How about negative 3? Right, you're going the wrong way. All right, so negative 3. So can I plug, so if my x is negative 3, can I plug that in and get a y value? Yeah, so let's go ahead and plug that in and give me a y value. So negative 3 squared minus negative 3 minus 6, and tell me what you get. Huh? I get 6. Don't you guys? Okay. So we know this is positive. So all my numbers in this interval are going to be positive. Okay. Now pick a number between this interval. 0. You could use negative 1 now, Aiden. But I like 0 better. And when I plug in 0, what do we get? So we do 0 squared minus 0 minus 6. And what do we get? Negative 6, right? Since that's negative, all of the values in that will be negative. All right, and then the last interval, give me a number in between 3 and infinity. 4. So let's plug in 4. So 4 squared minus 4 minus 6. And what do we get? 6. So again, this is positive. So all my values will be positive in that sense, right? Any questions with that so far? Okay. So now to graph. And we're going to put this on a number line right now. So we have Let's go -3, -2, -1, 0, 1, 2, and 3. Okay. So we know our main interval is between -2 and 3, right? Okay. -2 and 3. So we are not going to include. So we know we're going to have the values in between these. Okay. Now, we know, okay, if we chose numbers on this side of -2, right? We chose numbers to the left side of -2. What kind of numbers did we get? Positive numbers, right? So instead of looking at this inequality here, really it would be x squared minus x minus 6 is greater than 0, right? So anything to the left of -2 is actually going to be greater than 0, right? Because all of those values were positive, right? Okay. If we are in the middle of these two, okay, if we are in the middle of these two, we had we had what kind of answer? A negative answer, right? We got, when we plugged in 0, we got a negative answer. So our x squared minus x minus 6 will be what to 0? Will it be greater than or less than 0? It'd be less than because they're negative, right? Less than 0. And then anything to the right of 0, that equation would be what? Greater than 0, right? Because they were all positive values, okay? Right, now solving, okay? It's not responding, I gotta give it a few minutes. Okay, so now example 2, okay? We're gonna solve this. So if we wanna solve this, the first thing is we always have to set it equal to what? 0. So go ahead and set that equal to 0. Well, I kind of start this back over. Sorry guys, the computer's not working for a second. Okay. And then once you set it equal to 0, what should we do? Factor it. So go ahead and factor for me. Looks like opened everything back up. All right. All right, so from here to here. All right, so example 2, we're setting this equal to 0. So we subtracted the 6 over, right? All right, and now we're factoring it. So if you factor, what did we get as our quantities? Four x plus 3 and x minus 2. Is that what you guys got? Or were you still working on that? Does anyone want me to factor that for you, or are you good? All right. Now, what do we do with each of these? We set them equal to 0. So what are my two solutions, or my key numbers? -3 over 4 and x equals 2. So the nice thing about this, okay, yes, we're solving. So we know these are going to cross our x-axis at what? 2 and -3/4, because isn't, when your y is 0, aren't those your x-intercepts, which are my solutions? So this is where it actually, if this was equal to, we know this would be our actual answers, right? Now, if we actually kind of graph this, and we know it's going to be what kind of shape? What kind of shape would this be? a parabola, right? And would we shade above the parabola or below the parabola? We'd shade above it, right? So it's kind of actually shading in between those two, or in between the parabola, right? Okay. So really all the solutions within that shading would make this inequality true, right? Okay. Now, keeping going from that, okay? Because we're gonna look for the actual solution set of it. We know, again, as we talked about this, if we graph this, it's gonna cross at -3/4 in it too. And we're shading in the middle of this, right? So my solutions are in between that, right? And if my solutions are in between that, my actual solution set isn't going to be the values between all of that. Yeah, but we're going to keep going here for a second. All right, we're going to do it the way the book wants us to. Okay, now from this, so we got to do our testing intervals, right? So what are my testing intervals? We're going to go from -infinity to, what's my smallest number? -3/4, right? Then we're going to go -3/4 to 2, and then we'll go from 2 to positive infinity. So we're getting each direction of those, right? Each direction of that. Excuse me. So now we got to pick some numbers in between those intervals, right? So give me some numbers in those intervals. So between -infinity and -3/4. -1. Between -3/4 and 2. 1 or 0. I like 0 better personally. And then what about 2 to infinity? 3. All right, go ahead and find your values when you evaluate that for you. I'm going to give you a few seconds to do that. When you plugged in -1, what did you guys get? When you guys plugged in -1, what did you guys get? 3. So we know this is positive. When you plugged in 0, -6. So that's negative, right? I don't know, I put an X, negative. And then when I plugged in 3, what did you guys get? Huh? 15. And that is positive, right? So our solution is actually where it is positive. Why? Because it is greater than, right? It is greater than. So we want our values to be greater than 6, right? So if I plug in those numbers, it will always be greater than or 0 since we moved that 6 over, right? Since it's greater than. So our solution are the values between, between those solution intervals, those test intervals. So my solution set is from -infinity to -3/4 with the union of 2 to infinity. Now, if it was less than what would be my solution set? If I wanted less than 0, we would have to have the values that are less than 0. What kind of numbers are less than 0? Negative number. So I would have just used that one if it was less than. Okay. All right. Any questions on that? Okay. All right. Can we do the same thing for example 3? All right. Example 4. All right, x squared plus 2x plus 4 is greater than 0. Crap, it's already done. Yeah. And like I said, we don't have much more to go here, so you're good. All right. Yeah, and then are you coming today or tomorrow during 8 o'clock? Tomorrow. Yeah, that's fine. That's perfect. All right, solve the inequalities using the method in example 1. Okay. So looking at this, what's the first thing we need to do? We factor it, right? Well, can we factor this? Bye. Have a good one, Aiden. Let's think about this. Okay. We know if you think about your domain in this one is always what? All real numbers, right? Okay. So, and I can't actually factor this one, can I? No, right? Because if I factor, I would have to go through, there's nothing that multiplies before that adds to B2, right? So we'd have to use the quadratic formula to find our intercept. So let's go ahead and just pick any values. Okay, so give me a negative value. Negative what? Sorry. It's gonna stop working on me again. -1. Okay, so let's plug in -1 here. What do we get? Huh. 3. What do we notice? That is positive, right? Okay. Let's just plug in 0. Let's try 0. What do we get when we get 0? We get 4, and that is positive. Okay. What if we plugged in a positive number, like +1? What would I get? We get 7. It'd be positive again, right? Do you think there's any value I could plug into that would give me a negative value? No, even if I plug in like a -100, would I ever get a negative number? No, because if I square -100, it is always going to be bigger than 2 times that 100, right? Not -100. So in this case, every single value is going to be what? Positive. So what's my solution set if there's every single number is going to be a positive number? -infinity to positive infinity. Yeah. All right, if you look at B here, can we factor this one? What times what is 1 that adds B2? Isn't it 1 and 1? So we could factor this one, couldn't we? Yeah. So what is my value for x? -1, right? So the only solutions we have or test intervals would be -infinity to -infinity, or -1, and -1 to positive infinity, right? Are you guys okay with that? Now, could you plug in values? Give me a number that's in between -infinity and -1. -2, right? So let's plug that in. What's -2 squared plus 2 times -2 plus 1? What did we get? I'm sorry. 1, okay. And then give me a value, so that's positive, right? Give me a value between -1 and infinity. 0. And when I plug that in, what do we get? 1. Okay. Those are both positive. And what do you notice about these numbers? They're the exact same, right? Now, if we plugged in more values, would be okay, right? Now, what's one key thing that's different with this problem than all the other ones that we've looked at? Huh? Close. This has an equal to. What does equal to mean? It has to equal it, right? So this one actually only has one number that would allow that to be equal to, right? And what is that one value that allows it to be equal to? Huh? We know, you guys found it. It was -1, right? So you first thought that this would be, because they're both positive, would be also -infinity to positive infinity, right? But because of that equal to, it has to be equal to, right? With inequalities in this case. So the only value that actually satisfies this is what? What number? -1. So -1 is actually my only solution set. And again, these are our unusual solutions, is why this is kind of weird in that sense. So if it's equal to, we're looking for the values that actually make it equal to. Okay. All right. C, can we factor that one? Okay, so we can't factor that. So let's go ahead and pick some values again. So give me a -1. -1. Let's do -1, 0, and 1, right? Okay. So plug in -1, and what do we get? What? I'm sorry. 3. Okay, so that's positive. When I plug in 0, what do we get? 5. That's positive. Good. And when I plug in 1? 9. Positive. Okay. So right now, all of them look positive, so they all look like solutions, right? What's my inequality sign again? Less than. Are any of those numbers, when I plug in, less than 0? Give me numbers less than 0? No. So do we have a solution in this one? No. So my solution set is actually the empty set. There's no solution whatsoever. So do the signs matter? Yes, they do. The signs matter. And because all of these were greater than 0, that's why it was from -infinity to positive infinity. Okay. All right, and then look at this one. Okay. Can we factor this one? And what do we get here? X minus 2 times x minus 2. So x would equal what? 2. So what are my intervals? -infinity to 2 and 2 to positive infinity, right? Okay. Now, look at my inequality sign. So these values have to be what? Greater than 0, right? So in our intervals, they have to be greater than 0. So give me a value between -infinity to 2. 1. And when I plug in 1, what do I get? One. Yep, so that's positive, right? So is a positive value greater than 0? So that one looks like our solution, right? Okay. What about 2 to infinity? Give me a number. 3. So let's plug in 3. So 3 squared is 9. 9 minus 12 is -3. -3 plus 4 is 1. Is that positive? Yes. So could that be a solution? Yes, because it is greater than 0. Okay. What's the only value that doesn't work? Would 2 actually satisfy this equation? No, why not? Because it would equal 0 and not. That's why we're using the parentheses, not the brackets. Okay. Does that make sense to you guys? All right. Our rational inequalities now. Can we graph that? Or solve it? Yeah, we should be able to. All right. Can we set this equal to 0? Can you set this equal to 0? Yeah, I hope so. How would I move that 3 over? Subtract it. Equals, and I'm going to put an equal sign even though it's less than or greater than. Actually, I'll do that. Now, how can I combine these two? Same denominator. So 3 is the same thing as 3 over 1. So what is my common denominator? X minus 5, right? So if I want 3 over 1 to be something over x minus 5, what would I have to multiply the numerator by? X minus 5, right? So what is 3 times x? 3x, right? And what's 3 times -5? -15, right? Is less than or equal to 0. So let's go ahead and combine like terms now since we have the same denominator. What's 2x minus 3x? Huh? 2x minus 3x, negative x. And what's -7 minus a -15? It'd be a positive 8 over x minus 5. Equals or is less than or equal to 0. All right, you guys okay with this now? Now we have to test our intervals, right? So we got to find our intervals. So let's look at our denominator first, okay? Let's set that equal to 0. So x minus 5 equals 0. So x would equal 5, right? So we're going to look from -infinity to 5. Then we look at the numerator. So -x plus 8 is equal to 0. So x would equal, I don't know why I hesitated for a second. X would equal 8. Yep. So that would be 8 to positive infinity. And what's my middle interval? 5 to 8. It's okay with that? All right. Now, can you pick values between here and plug them in? Okay. So what's a number in between -infinity and 5? 0. That's a good one. Between 5 and 8? 6. And between 8 and infinity? 9 or 10, whatever you want to do, right? All right, so go ahead and find those. Now, what's my inequality sign? Has to be less than or equal to 0, right? So go ahead and plug those in and find my values for me. So when you plugged in 0, did you guys get 8 over -5? Okay. So is negative 8/5 less than or equal to 0? Yes, so is this a solution set? Yes. Okay, let's plug in 6. Negative 6 plus 8 is 2 over 6 minus 5 is 1. Is 2 over 1 less than or equal to 0? No, so is this a solution set? No. All right, let's try 9. What's negative 9 plus 8? Negative 1. 9 minus 5 is 4. Is negative 1/4 less than or equal to 0? Yes, so is this a solution set? Yes. So my solution set would be from negative infinity to 5, and then from 8 to positive infinity. Okay, that would be my solution set. Does that make sense to you guys? Now, why don't I use the brackets? Because if I actually plug in 5, would that work? No, because 5 minus 5 is 0. And can you have 0 in the denominator? No. Okay. All right, any questions with that? Okay. Obviously, last one is a story problem. Again, that's in the book there. I will have the written out problem how to do it online here shortly for you. Okay. All right. Oops, where did it go? All right. Do you guys have any questions?